So I've got most of the metal I need. I need to give it a clean now, it's all full of shards. It's actually fairly well cut. Not 90 degrees perfectly, but it'll be close enough for my purposes. Oh, that stupid dog. Chess, what's up? There he is. He doesn't like the noise they're making. I just found out this is a little bit mangled. So here's the rough shape of it. It's not the final shape. It's missing one of these because that's a little bit bent. It'll still be in here though. These upper segments get raised a bit, as do these second segments here and so on. You can see roughly the size it'll take compared to my other machine. This shed's in a bit of a mess right now because it's being cleaned up. And here's the aluminium sections. This bit here is mainly spare. It was literally cheaper for me to buy a 6.5 meter length to get the bits I want than it was to get the exact lengths I needed from Bunnings, and Bunnings don't have this size exactly, so what they had was even smaller. I had to buy a dedicated argon bottle. We've got argon carbon speed shield, as it calls it there, but you just can't TIG weld with that with the aluminium. It just leaves it all carbonized and horrible. And there's the TIG handpiece and the rest of the bottle. And of course the MIG welder for the steel. So yeah, all the welding stuff's ready. Some things are going to be bolted, the critical things that I don't want to warp. Some of the structure will be, tacked. It's going to be a bit of a mix of things. So I figured one way I can help smoothen and equalize this surface for mounting the rails is to use a flat piece of stone that's been polished flat. So I know that's a good reference surface, and it's hard, that I can use some sandpaper on. And it's also heavy, so I don't have to hold it down. I'm just trying to keep the sandpaper sliding along that, and I run it up and down the whole length. I've been doing it for a little bit. As you can see, it's taking off the highest spots, which of course is almost always these edges. But yeah, it's doing a pretty good job. So I'm going to continue doing that.
So what I didn't mention before is the reason for trying to smooth this rail down. The paint and obviously the high edges you saw in the corners are going to upset mounting a precision linear rail element and a rack and pinion.
So it's going pretty good. It's getting fairly uniform by the looks of it, except for the edges, but that's to be expected, and I can't do much about it anyway. Alright, so my primary focus right now is getting these two beams to be the right length. I have my design here. Focuses. There we go. The 1217.5-ish, because this is all going to be welded, and this is not part of the precision aspect of the machine. It can be plus or minus a millimeter or so. So yeah, I've got to get these to that length in respect to inside of that beam and the inside of that beam.
So I'm just marking out a few contoured edges and cutting a few of these tubes to length, because of course when you have one tube mating up to the surface of another, the edges of the tubes are a little bit filleted or curved, so you have to cut a matching contour out to fit against that if you want to do a nice full round weld around the whole thing. And some of the lengths I have are a bit oversized, because if you have any real precision size tube that you want, you never rely on the store to cut it for you, because they're always, plus or minus a few millimeters. They can't guarantee any precision. Well, they could, but you have to pay for that, and they have to obviously offer that service as well.
Just to show you more what I mean by the bevels here. See, I have to match this bevel if I want to get a nice weld in there. And of course this side is exactly the same. Alright, so I'm ready to start welding this up. I've just been doing a bit of practice with the right, well, not exact thickness, but similar thickness variants of material. So I've got my settings set in for this. This is a thicker bit joining a thinner bit. It's got it all angled up correctly. I trust this plate more, so I've got those a nice backbone. Dad suggested I brace it like this to stop it from warping. And then I'm going to preheat it all and then put a fiberglass blanket over it once I finish welding it to.
Good tack.
Yep.
Good tack. Good solid tack.
Just in case you didn't catch that, tacking this together is fairly important before you do the main welds. It helps stop it from moving about when you do your full weld, because it's going to try to pull a little bit on either side as you're doing a big long bead of hot metal essentially, and as it contracts, and the tack will help stop that. So I'm heating it up to try and get rid of moisture, but also to help alleviate the warp that you'll get from welding. If the whole lot is quite hot before you start the weld, it'll minimize that thermal shock you get when you pump a huge amount of heat into it, and then that huge amount of heat rapidly cools away from that tiny spot.
Yeah.
Yeah, good.
Like a stitch. You do a stitch there and a stitch there.
Yeah, okay, you can do that.
Clean hot dip there?
Yeah, it does help. I didn't even realise it myself.
So for most of the welds on this structure, I've done backstitching. So instead of doing the weld all the way from the top to the bottom of a length or a side, I do it in small stitches, essentially moving in a backward direction from where you started or finished a weld, should I say. The whole reason for that is to lower the amount of warp you'll get. So the longer your weld is, the more it's going to pull in that direction that you're welding. The backstitching sort of helps break that up. And once again, because this is all preheated, I put the blanket on to help the heat spread and stop it from dissipating so quickly, so it's a bit more normalized.
So I've got this in the vise. I've got the laser on, showing a line. There's a little black dot there showing where it is centered. I'm going to cut this bead after that stuff, and then if it's warped, that should move a little bit. Yeah, tiniest bit. Oh well. That's good. Didn't warp that much at all. That's better.
So my welding skills have improved dramatically throughout this whole project, which is what I've been aiming for. My dad used to be a welder along with many other things in the past, so he's shown me a lot of things throughout this whole thing, and just noticed that I blind him a little bit. But yeah, he's shown me how to do all these things and telling me how to improve here and there. It's been a great help. I found when you do backstitch welding, which is just a method of welding to help eliminate or at least mitigate warp, it gets confusing because you're doing lots of little welds here and there. So it really helps to scribe onto the steel itself the sequence of your welds and the direction you're going to do them. So just put, a 1, 2, 3 and a little arrow pointing where you're going, and just to think about it and look at it beforehand, because you've really got to do all these welds quick while you've got your metal preheated, because you don't want it to cool down too fast. So I'll just show you a quick time lapse of doing a full weld on one side. I'm really starting to master it by now. So it's starting to get big now. So I'm just placing one end on that big flat plate, getting it relatively level by shoving a packer under the far end to lift it up. And I clamp all the bits down. I leave my overhanging section that I'm going to weld, and I use an angle angle bracket to sort of guarantee that I've got it roughly within the angle I want. I usually test it a bit with the digital level to make sure it's where I want. Then I start my preheating, as you see here. I've managed to get it to the point where I can do it by myself. I don't need my dad's help maneuvering it around quickly as I do the welds. You'll see that in a moment. So here we go. So I quickly plop it down. I do horizontal welds, then I prop it up and do some vertical downs, and then I do the top.
Yeah, it's they're all within about 0.2 degrees of what they're meant to be. When I say they're all within 0.2 degrees, I mean one is used as a reference on the digital level, and the others are in 0.2 degrees of that, roughly. So I'm just getting ready to do these little central supports. They're the diagonal. That's where they go. The diagonal portions that help stop this side from skewing. So I've just marked out the distance I need to cut these at. Yeah, it's the same as this distance here. I'll cut these, and then I cut these diagonal portions, which is a lot more involved. And then I tack it up, make sure it's all good, and then I do the full welds. So obviously it wasn't, see there? Yep. About 3 millimeters out.
You can pull that and weld it.
What are you trying to do?
Bend it.
We're trying to do lottery stands. We're doing a mini jig.
Just keep at it. It does bend a little bit each time, yeah.
Yeah, we'll try it now. Do it little and often.
I'm just going to cut some of this down to size. I'm filling in these holes so I can put little screw, adjustable screw feet in here. And the other thing I'm going to do is place those casters. Alright, that's 6 little plates done. Now I've just got to mark the centre and drill out a hole and tap it. Alright, so I just tapped all these on the mill. I tried the drill, but the belts just slip. Whereas this mill you can have a really low gear reduction, and this actually spins at a very controllable speed. First thing I actually did was tap it by hand, but it was wonky in out. But this is nice and square. Yep, they're all done. They're tapped and they're ready to weld in now. And this is what happens when a bead of molten metal makes its way through your shoe. So I found these leather covers, but one problem, I don't know if you can see it, that there, that's the hole. These are hard cap shoes, keep in mind. Obviously they're plastic hard cap, or if they're metal it just snuck through there and then went down there. But that's where that bead of molten metal went through, and this doesn't just reach it. This one does, but this one's a tiny bit shorter. So I'm ready to weld these in. I'm not going to weld them flush like this. I want them inset because I want to sort of hide the bead on the inside. And of course, just attaching one of these plates to the other with a spacer means I can reliably keep this level every time, except for the very last one. The very last one I'll have to get creative and figure out what else to use to level it. Alright, these are all welded up. They're going pretty good. I changed the patterns I used on these holes. First I did it all the way around, but then I realised when you have a thick bead here and here, it will probably limit the the flat surface you can place the lock nut on. So then I started doing that pattern. Here's the thicker steel portion. See, it hasn't blown through, but it's cavitated a fair bit there. And here's the other one. The welds don't look as nice, but it's hard because this is galvanized. I have ground off the surface as much as I can, but it still seems to be there. I mean, like, there's the normal steel weld, so I can do a decent weld. It's just the metal here, you can hear it too. It sounds fizzy as opposed to crackly. I haven't got much experience welding galvanized steel, so yeah, this was my first go at it really. Yeah, they're good. I trust them to hold the thing up.
So back to my potato camera here. I'm finally starting to assemble this thing, just using those right angle brackets and measuring it all with an angle, making sure it's all 90 degrees to each other. Nothing special there. The hardest thing is, finding shims and packers to get things into place. And then I figured it'd be a better idea to clamp some flat surfaces to the other reference surfaces that they are meant to be in line with, which is what I'm doing here. So then I remove the packers because I don't need them anymore. Then once I finish that and I'm happy with the measurements and I see that it's all where it should be, I just tack it all together. So after I finished welding up some of the front, I checked the diagonals. It was a little bit out, so I used a come along to sort of pull it back in square. You measure the corner to corner diagonals. As long as those two angles, as long as those two lengths are the same, then you've got it pretty square. Then I measure like all the other angles just to keep myself sane.
So with these legs, I want to fill them with sand just to give a bit of mass to the outer perimeter and a bit of vibration damping. But as you remember, I had the screw jack feet, these, so I can't just pour sand directly in there, or concrete or whatever medium I want to use to weigh it down and deaden the vibration. So I need to make little caps to go over that. And I lowered it down to make sure the nut size fits in there. So I've just marked out 10 centimeter increments. If you wrap like a hardish piece of card or paper will do, I'm pretty sure, as long as you get your overlap in line. I can use this as a cutting reference. Found the perfect thing to cap these off with. Milk bottle caps. And these are how they look when they're glued up. One thing to note, let me see if I can zoom in there. The bead on the inside will not stick to the inside of the cylinder, it'll bubble inward like a donut. So you get a pen and you just use the pen to squish it up against the outside. Alright, so I had to use double-sided tape to hold the nuts down because super glue didn't like sticking to this plastic apparently. It was on it. Those bloody birds infesting this area. Okay, that's on. Not much to see really, it's just sitting down there. You can see some of the silicone got stuck to the wall.
So I think I'll end this episode here. It's been going on for over 20 minutes now. Last thing you see is me just adding an extension to the rail because I of course ordered it too short. These are like the main rails that the linear rails and the rack pinion will attach to. I think the next episode I'll show you how I make the pads that the side rails mount onto and how I sort of accurately place the screw holes that the linear rails will mount to and the racks, and show you that process and mount that hardware and try get it all lined up. That's the real precision technical aspect of this build.